Hello, this is Shakil Ahmed. In this tutorial, we will discuss about analysis of variance. Next, we will discuss about one-way ANOVA, and in next video, we will discuss about two-way ANOVA or repeated Mayer ANOVA. Of variance, we are interested in comparing a quantitative variable across multiple more than two independent groups. Here, we are two groups are independent. It's just an extension of independence of the t-test for more than two groups. So we have again the sports data where we have, for example, average glucose level, our response variable, and we can take work type as grouping variables. We have 2 to 4 groups. So first, we can check the number of groups and the number of duration in each group, and we can also check the mean and standard deviation in each group using the command group by. This we have the data frame, and we are making groups by work type, and then we are finding the cones, mean, and standard deviation for each group. And then we can apply, we can also check for the box plot to see whether the two groups, the mean of the three groups or the summary statistics in the 3 to 4 groups are same or not. You can just have an idea of about the comparison using the box plot. So you can make a box plot before going far enough. If the box plots are displaying this equal mean or median, then you don't need to apply the analysis of variance. So analysis of variance is used to quantitative variable. Your variable should be quantitative and groups should be independent, and the group variances are assumed to be same, and the each group should the response variable in each group should follow a normal distribution. So you need to check all these assumptions before going to apply the analysis of variance. So here is the codes for analysis of variance in Python. You need to import the states model API as SM, and then states model formula API, and the formula is the ordinary least square. Basically, we are assuming just an ordinary least square as the grouping variable as the response as the axis, and response variable as the continuous variable. So we can just perform this using the model, and then we are given OLS. This is the dependent variable, and the variance which is given the sum of square, and the residual sum of square, and the degree of freedom. We have 5 groups. So the degree of freedom is 4, and this is the number of observation, total observation minus the total degree of freedom for the groups. And we have an F statistic of 16.6 with the value that is strongly significant. So whenever the test statistic is significant, the p-value suggests that the results are significant, the means are not equal. So we need to perform the post-hoc test to see which pair of the means are not equal and which pairs are equal. So among available post-hoc tests, the Tukey's honesty significant different test that is called HSD test is mostly applied statistical test for pair comparison. So just import pairwise Tukey's HSD from states model, and then states, and then multiple comparison tests. So among multiple comparison tests, we just imported this test. And we are just using the formula, applying the formula pairwise Tukey's test, and your ambiguous variable is the response variable is the glucose level from the data frame, and third type is your independent variable, the grouping variable. And then just print the Tukey's test, you will see the results. And it's comparing all the groups: government job versus never work, government job versus private, government job versus self-employed, and government job versus respondent is a child. So we have only there is a difference in glucose level in these two groups. All other are same. And similarly, we found significant results for these three pairwise comparisons. It compares all possible pairs in the groups. For example, we have five groups, so we can compare five C2 10 comparisons we can make between different groups. And here are the mean differences and the p-values and the lower and upper bounded interval and for the difference, and then reject. Reject false means we are not rejecting. Reject true means we are going to reject the null hypothesis where the two means are not. That's all about the analysis of variance.